Is time travel possible? Exploring the limits of temporal exploration, time travel has long captivated human imagination, from H.G. Wells' seminal novel The Time Machine to the popular Back to the Future film series. But beyond fiction, is time travel a possibility? This article delves into the scientific, philosophical, and theoretical aspects of time travel, examining whether it might be achievable within the laws of physics. Understanding time travel. The basics. Time travel refers to the concept of moving between different points in time, akin to moving between different points in space. While time travel is a staple of science fiction, its feasibility in the real world hinges on our understanding of the universe's fundamental laws. Einstein's theories and time travel. Einstein's theories of relativity provide the most credible framework for considering time travel. Special relativity. According to Einstein's special theory of relativity, time dilation occurs when objects move at speeds approaching the speed of light. This means that time for a rapidly moving object would pass more slowly compared to a stationary observer. This form of time travel into the future has been experimentally verified with atomic clocks on high-speed jets and in particle accelerators. General relativity. Einstein's general theory of relativity introduces the idea that massive objects can warp space-time. This warping could, theoretically, allow for paths through space-time that could loop back on themselves, creating what is known as a closed time-like curve, CTC. Such curves might allow for travel back in time, but they are purely theoretical and face numerous paradoxes and practical challenges. Theoretical models and paradoxes. Several theoretical models have been proposed to explore the feasibility of time travel. Wormholes. Wormholes are hypothetical passages through space-time that could create shortcuts between distant points in the universe. If stabilized, a wormhole might allow for time travel if one end is moved to a different time. However, creating and maintaining a stable wormhole would require exotic matter with negative energy density, which has not been observed. Cosmic strings. These are hypothetical one-dimensional defects in space-time that could theoretically warp space-time enough to allow time travel. However, cosmic strings remain purely speculative and have not been detected. Quantum mechanics. Some quantum theories, such as those involving particles in superposition or entanglement, hint at potential time-related effects. However, these theories are still in their infancy and do not provide practical methods for time travel. Paradoxes and challenges. Time travel, especially to the past, introduces several paradoxes. The grandfather paradox. This paradox questions what happens if a time traveler goes back and prevents their own grandfather from meeting their grandmother. If their grandfather never meets their grandmother, the time traveler could never be born, creating a logical contradiction. The bootstrap paradox, also known as the ontological paradox. This involves objects or information that exist without ever being created. For example, if someone travels back in time and gives Shakespeare a copy of his own plays, which Shakespeare then publishes as his own, the question arises, where did the plays originate? Current scientific consensus. As of now, time travel remains a theoretical concept with significant scientific and philosophical challenges. Experimental evidence. No experimental evidence supports the existence of closed time-like curves or stable wormholes. Current technology and understanding do not allow for practical time travel. Physical laws. Many physicists argue that time travel to the past might be impossible due to violations of causality and fundamental laws of physics. Future prospects. Advances in theoretical physics, particularly in quantum gravity and string theory, may provide new insights into time travel. However, these are speculative and require validation through experimental evidence. Philosophical and practical considerations. Even if time travel were possible, it would raise profound philosophical and ethical questions. The ability to alter past events could have significant consequences for history, personal identity, and the nature of reality. Moreover, practical considerations, such as the energy requirements and stability of hypothetical time travel mechanisms, pose significant hurdles. Conclusion: while time travel captivates our imagination and provides rich material for scientific speculation and science fiction, it remains an elusive concept. Current scientific understanding, based on Einstein's theories of relativity, suggests that while time dilation and travel into the future are theoretically possible, traveling back in time presents formidable challenges. As our understanding of the universe evolves, time travel may remain a tantalizing possibility or a profound mystery, inspiring both scientific inquiry and creative exploration. More interesting writer article: ChatGPT, is time travel possible? A journey through the mysteries of time travel has fascinated us for generations, offering tantalizing possibilities that stretch the boundaries of our understanding. From the literary masterpieces of H.G. Wells to the high-speed escapades of Marty McFly, the idea of journeying through time ignites our imagination. But beyond the realm of fiction, is time travel a plausible concept within the confines of modern science? Let's delve into the intriguing world of time travel and explore what science, philosophy, and cutting-edge theories reveal about this enigmatic phenomenon. The fascination with time travel captures our collective imagination with its promise of rewriting history or glimpsing the future. Imagine visiting ancient civilizations, meeting historical figures, or peering into a distant future where technology has transformed society. The allure of time travel is not just about changing our past or future but understanding the fundamental nature of time itself. Einstein's time-warping theories: Albert Einstein's revolutionary theories of relativity provide the foundation for our scientific exploration of time travel. Special relativity, the time dilation effect. Einstein's special theory of relativity, published in 1905, introduced the concept of time dilation. According to this theory, as an object approaches the speed of light, time slows down relative to a stationary observer. This means that astronauts traveling at near light speeds would experience time more slowly compared to people on Earth. Although we can't yet achieve such speeds, experiments with atomic clocks on high-speed jets have confirmed time dilation, showing that time travel into the future is scientifically feasible. General relativity, space-time and gravity. Einstein's general theory of relativity, presented in 1915, takes a broader view by integrating space and time into a unified fabric known as space-time. Massive objects like stars and black holes warp this fabric, creating what we perceive as gravity. This warping of space-time suggests that if we could manipulate these distortions, time travel might be possible. For instance, the concept of a wormhole, a theoretical tunnel connecting distant points in space-time, might allow for shortcuts across time. However, stabilizing a wormhole requires exotic matter with negative energy, which remains speculative. Theoretical constructs and cosmic wonders. Several advanced theories explore the feasibility of time travel. Wormholes, cosmic shortcuts. Wormholes are hypothetical passages through space-time that could theoretically connect different points in time as well as space. Imagine a wormhole as a cosmic tunnel with two ends in different locations and possibly different times. While the concept is mathematically intriguing, creating or finding a stable wormhole poses enormous scientific and engineering challenges, including the need for exotic matter. Cosmic strings, the time-warping threads. Cosmic strings are hypothetical one-dimensional defects in space-time, predicted by some theories of the early universe. If they exist, they could warp space-time significantly, potentially creating loops or closed time-like curves that might allow time travel. However, cosmic strings are still theoretical, and no observational evidence supports their existence. Quantum mechanics and time travel. Quantum mechanics, the science of the very small, introduces ideas like quantum entanglement and superposition. Some interpretations suggest that particles can affect each other instantaneously over distances, hinting at the possibility of time-like effects. However, these quantum effects are not yet understood well enough to provide practical time travel mechanisms. Paradoxes and philosophical quandaries. Time travel, particularly to the past, raises complex paradoxes and philosophical questions. The grandfather paradox. One of the most famous paradoxes is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you would never have been born. This creates a logical contradiction. If you were never born, you couldn't have traveled back in time to alter the past. The butterfly effect. Even small changes in the past could lead to unpredictable and potentially catastrophic consequences for the future. The butterfly effect illustrates how minor events can have vast, unforeseen impacts on the timeline, challenging our ability to predict or control outcomes. Personal identity and free will. Time travel raises questions about personal identity and free will. If you could change past events, would you alter who you are today? And if you could see your future, would it change your choices in the present? The current scientific landscape. While time travel remains a popular topic in science fiction, its practical realization is far from our current technological capabilities. Theoretical physics provides intriguing possibilities, but experimental evidence is lacking. The energy requirements and stability needed for time travel mechanisms, such as wormholes or cosmic strings, are beyond our present reach.